Okay, so we are back again. Just before going to the next problem, let me tell you, for DC circuits, I am solving so many problems and for you, but it is DC circuit, so it doesn't take much time to solve. But when we will come to the single phase and three phase AC circuits, at that time number of examples will be less, because their complex number will be involved, right? So that's why, but theory, but whatever theories and your theorems, the laws, whatever we are applying, all these theorems we will see later, right? So all these things similarly applicable to AC circuits, but at that time examples will be small, number of examples will be less, but in DC circuit varieties of problem I am showing, such that you should not have any confusion or any sort of problem. So let us come to this problem, right? So this circuit is like this. So this is your example 12, right? In this problem it has been asked that just hold on, it has been asked that you have to find out V1, this is node 1, V2, it is node 2, and at node 3 V3, these three nodal voltages, and then you have to find out this current I2, right? These are the four quantities that you have to solve for this circuit, right? And here current is given I1, other branches currents are not given, but we have to assume, right, some current, and accordingly we have to solve. For example, suppose if this branch current is I3, say I am taking in this direction, and this current is say I4, right, and this current, say if we take I5 for example, right, because so many examples we have solved, so later actually we didn't write all I3, I4, I5 anything in the problem, directly we have written, but when we will make such things, first thing is what will be the I1, we have to understand. Look, at the beginning we have told any node voltage with respect to this reference node, this is ground, so reference node voltage say V0 is equal to 0, this we know. So first you have to find out your what you call the expression for V1. Just for your understanding, looking at the circuit, you may have some kind of thing, but if I make it separately, actually this V1 with respect to the ground, that means suppose this is my V1 and it is from here to here, it is from here to here, right? This is negative and this is your positive, right? So this way, so what you can do is, first you apply your KVL like this, you apply KVL like this, right? You apply KVL like this. If you have any confusion, I can draw a different diagram, the same diagram but in different way. Say this is my plus minus, this is my 12 volt source, that means this one, right, and this is actually 4 ohm resistance, this is 4 ohm, that means this one, right, and this is your current I1, and here this is your node 1, this point after 4 ohm, this is your node 1. So this point with respect to the reference ground, that's why I have made it from here to here. So this is actually your V1, this is V1, say plus minus. Now you apply this way, you apply your what you call that KVL. So it is encountering minus terminal first, so minus 12, right, plus 4 into I1, this is 4 into I1, this is 4 ohm and this current is I1, then plus V1 equal to 0. That means my I1 current will be your 12 minus V1 divided by 4, right. So that means here this current again rewriting here. So I1 is equal to your 12 minus V1 by 4, this is my I1, right. So first you have to apply your what you call that your KCL at node 1, this is node 1. So if you take I3 will be V1 minus V3 and this resistance is 6, so it is V1 minus V3 by 6, this is your I3. Similarly for I4, I mean here in this branch I4, the resistance is 6, so I4 is equal to your V1 minus V2 upon 6, right. So at this node 1, I am putting it here. Look, I1, this is the incoming current, and I3, I4 is outgoing current. So, I3 plus I4 if you apply KCL, right. Actually, on this making all this exercise here itself, such that things will be understandable for you, right. So, now let me clean it. Therefore, I mean your just hold on. If you, that means if you apply your what you call KCL at node 1, so whatever we wrote, it will be 12 minus V1 upon 4 is equal to this V1 minus V3. Directly you can write by 6, this direction is the current and this direction whatever just I wrote, I3 and I4. So, this is I3 and I4 is actually plus your V1 minus V2 upon 6, right. So, this is your what you call, that is KCL at node 1. So, let me clear it, right. That means at node 1, this is the equation is written, 12 minus V1 upon 4 is equal to V1 minus V3 upon 6, right. Upon simplification, 7 V1 minus 2 V2 minus 2 V3 is equal to 36. This is equation 1. Similarly, you apply your what you call that your KCL at just hold on, KCL at node 2, here you apply, right. So, this current we took, I4 and this current we took I3, right, and this one we took I5. One current source is there, 2 ampere current source is there. So, if you apply your what you call this and it is I1, I5, another current here you can take here, say this current is here I6. Previously, I did not see because it is becoming clumsy. So, if you apply your KCL at node 2, then this I4 is incoming. So, this current is incoming, that is I4, right, but other current, that I6 and I2, it is leaving the terminal, is equal to your I6 plus I2, right. So, because we are applying your what you call KCL at node 2. So, in this case, so I4 is equal to your V1 minus V2 upon 6 is equal to your I6, that is this branch current is I6. So, it is V2 minus V3 upon 6 plus this is your ground potential 0, right. So, it will be, and this is your what you call V2 minus 0 divided by 12, because this is 12 ohm resistance. So, this is your, if you apply your what you call that KCL at node 2, this is the equation. So, let me clear it. So, that means this is the at node 2, this is the equation, right. So, V1 minus V2 upon 6 is equal to V2 upon 12 plus V2 minus V3 upon 6. So, upon simplification you will get 2 V1 minus 5 V2 plus 2 V3 is equal to 0. This is equation 2. Similarly, at node 3, if you come at node 3, this is your node 3. So, similar way you can apply your KCL. So, not showing it here because this 2 ampere current is entering, right. This is this 2 ampere current entering into the node, and this one also, that is your I took I3, this I3 is entering here, right. And another thing is this current I6 also entering here, and this current I5, it is leaving this terminal. So, basically it will be 2, because this 2 ampere current entering terminal plus I3, this is entering, plus I6 is equal to your I5 at you apply KCL at node 3. So, similarly, that means you know I3 is equal to your what you call V1 minus V2 upon 6, and I6 is equal to V2 minus V3 upon 6, and I5 is equal to your V3 upon 12, right, because here it is at ground potential. So, you put it and let me clear it, and accordingly you will get this one, right, and that is your at node 3. So, at node 3, this is your, this is the equation, right, whatever I wrote. So, upon simplification you will get this is equation 3, right. So, solve equation 1, 2 and 3 the way you want, Cramer's rule or anything, you will get here. So, we have solved using you can write in this forms that your Ax, that is your x is equal to here actually V1, V2, V3 is equal to this equation. So, and you solve it the way you want, Cramer's rule. So, you will get V1 is equal to 12 volt, V2 is equal to your 72 by 7 volt. This is your V1, just hold on, this is your V1, this is your V2, 72 by 7 volt, and this is V3, and the current I1 is 12 minus V1 upon 4. So basically it's a 0 ampere current, and you have to find out power dissipated in 4 ohm resistor, that is 0, right. And second thing is that your what you call power in the remaining 5 resistor, right. So power in the remaining 5 resistor is your this I have written, right, just hold on. So this, there are 5 resistor, 4 ohm, 6 ohm, 6 ohm, 6 ohm, and one he told that across that power, because this I1 current is becoming 0, so I1 is becoming 0, so power dissipated here is 0, right. So I1 is 0, so rest is 1, 2, 3, 4 and 5, right. The 5 more resistors are there. So this is an exercise for you, I have written, but little bit you also do. This is an exercise for you. This is the power in the remaining 5 resistor. This is coming actually. This is an exercise. You please do it. This is very simple thing. You please do this one. Right. A very simple thing. Find out current in terms of your, basically it's I square R. You find out in general is that V1 minus V2 upon whatever I is coming, and multiply by your that I take a square and multiply that R of that branch, right. So ultimately you will find this way it will come. So it is an exercise for you, and answer will be 27.42 watt. So voltage across 2 ampere current source also 96 upon 7 volt, right. And let me clear it. And power supplied by 2 ampere current source is 90, it is V into I. So V3 is the voltage across the current source. This is your, because if you look into the circuit, that this V3 actually this voltage is V3, right. The way we write that, let me clear it. Actually this voltage, it is V3, right. So and 2 ampere current is entering, so power supplied by the current source is V3 into 2, right, whatever it comes. So let me clear it. So that's why it or it is 96 by 7 into 2, so 27.42 watt. And look to 27.42 watt here also. So if you see that all the power supplied by your current source, because in the circuit I1 is equal to 0, that means power supplied by voltage source is 12 into I1, but I1 is equal to 0, that means this voltage source is not supplying any power as per this circuit configuration is concerned, right. So all the power supplied by the current source only, right. So this one. Now next you come to this problem. Using nodal analysis, you determine V1, V2, I1, I2, I3 and I4 of the circuit as shown in figure 18, right, this figure. So here you have to find out that what is your, what you call that your I1, I2, I3, I4 and V1 and V2. So question is how to solve it. Look, one voltage source is there in between your two non-reference node V1 and V2, and one resistance is also here, 2 ohm resistance, right. First you have to find out, before moving that, first you have to find out, I have told you earlier also, first you have to find out that what is your I2, right. So if you look into that, this is reference voltage, this voltage anyway is 0, V0 0, and this is your V1 and this is your V2. That means this voltage actually V1, right, this will take plus, this is minus, and this voltage, this is another voltage is there, it is V2, right. So this voltage V2, right, so this is plus, this is minus. So this voltage actually V1, V2 is a nodal voltage with respect to the with reference to the ground, right. So in this, first you have to find out I2. So here you first apply KVL. Say we have taken clockwise, you take clockwise or anti-clockwise, doesn't matter, answer will remain same, right. So if you do so this way, then look how things are coming. First it will be your I am making it here, say 2 into I2, because this is the current I2, here plus terminal here, this is plus, so it is plus V2, then here it is minus, it is encountering minus first, then minus V1, right. Then it is moving like this. So, again encountering clockwise it is going, encountering plus terminal first. So, plus 32 is equal to 0, right. That means here I am writing for you, that means my 2 I2 is equal to, right, it will be V1 minus V2 minus 32, right, that is 2 I2. That means my I2 is equal to V1 minus V2 minus 32 by 2. This is my expression for I2. The first you have to understand that what will be the I2. So, I2 will be V1 I hope previously also couple of such example or more we have taken. So, from that you can find out there should not be any scope of confusion, right. So, that means I2 expression, because I2 is needed, because we will apply KCL at node 1 and KCL at node 2. So, I2 is needed. So, this is the expression for I2, V1 minus V2 minus 32 by 2, right. So, let me clear it. So, that means now you have to apply your what you call that your KCL at node 1. Say if we apply, right, if we apply your KCL at node 1, right. So, 9 ampere, this is a 9 ampere current source. So, 9 ampere current is entering here, this is 9 ampere, right. And now we have to write down I1, I2 we wrote, right. So, basically if you apply this 9 ampere current is entering into the node. So, and other this I3, then I2 and I1 all are leaving the node. So, that means if you write, it should be I1 plus I2 plus I3 is equal to 9, right. So, because we are applying this 9 ampere is entering this and I1, I2, I3 actually leaving the node 1. That means I1, I2 I told you. Therefore, I1 is equal to, this is V1, this volt reference ground potential is 0. So, basically I1 writing here for you. So, I1 is equal to your V1 upon 5, right. This is V1 upon 5, and then your I3 is flowing like this. It is V1 4 ohm, then it is V1 to V2, the 4 ohm resistance is connected. So, here I am writing your I3 is equal to V1 minus V2, V1 minus V2 divided by this 4, right. So, put I2 expression I have told you, then put I1, I2, I3 everything is equal to 9. This will be the first equation, right, in terms of your what you call that your V1 and V2, right. And so, let me clear it, right. So, if you do so, then this is your at node 1, this is the equation, right, whatever I said, right. And this is your what you call this is that equation, right, is equal to 9. So, I2 I told you V1 minus V2 minus 32 by 2. So, if you simplify, so this is your equation 1, right. Similarly, you apply KCL at node 2. Let me clear it. Right now, I am little bit slow, but later we have to increase the speed, otherwise it will be difficult to accommodate the time. Now, next one is your node 2. So, this is your what you call that 4 ampere current is entering into this node, this is 4, right. And after that you apply your what you call that your KCL, look 4 and I2 and 4 ampere, these two are entering into the node. So, I2 plus 4, these two are entering, right. No, another one is there, I3 is also entering, this current I3 is also entering, I3. So, plus I3, right, is equal to this I4 is leaving, is equal to I4. So, 4 plus I2 plus I3 is equal to I4. So, I3 we have written V1 minus V2 upon 4, right, and your I4 is equal to it is simply you can write V2 minus 0 upon 10, basically it is V2 upon 10, this is I4, right. And your I2 expression already we have got V1 minus V2 minus 32 by 2, right. So, substitute all, then you will get this thing. So, let me clear it, right. So, at node 2 this is that equation, right. So, upon simplification you will get 15 V1 minus 17 V2 is equal to 240, and you solve equation 1 and 2 you solve, because only two unknown V1 and V2. If you solve, you will get V1 is equal to your what you call this 50 volt, right. V2 is equal to 30 volt, and I1 is V1 by 5. So, we solve I1 10 ampere, I2 V1 minus V2 minus 32 by 2. So, it is I2 is equal to minus 6 ampere, that is current is actually flowing in other direction, whatever direction shown in the circuit is flowing in other direction. Then I3 is equal to 5 ampere and I4 is equal to 3 ampere, right. So, there is nothing your what you call there should not be any confusion on solving this if you get all sort of I mean a difficult problem, simple problem, all sort of things we are considering. So, let me clear this, right. So, next one is determine the node voltages V1, V2, V3, V4 of the circuit shown in figure this 19, right. So, you have to find out V1, V2, V3, V4. Listen, this is there are certain things that you have to little bit when you solve the problem, look at the problem carefully before doing anything. This is actually a common node, because it's basically these two are connected together. So, if it is V3, this is also V3, right. Similarly, these two nodes are common node, because there is no electrical element in between these two. Similarly, this point and this point it is same, right, because no electrical element is there. So, basically if here it is V4 means here also it is V4, if it is node number 4 means this is also 4, right. Another thing is that an intermediate point V2 also it has been asked you find out, right. So, V2 later we will find out. Basically, you have to see the how many nodes are there. Basically, we have 3 nodes, one is here, first you look into this, one is here, then another is here V3, another is the V4. All these things you apply KCL, right. So, then after solving this, when you find out the current and other thing, then you can easily compute V2, that we will see. So, basically these nodes are common, these two are this and this it is a common node. Similarly, this is a common node. A little bit you have to first understand looking at the circuit, and then you can solve it, because no electrical element is involved between in this wire and here also, right. With this, let me clear it, and of course, here you have one voltage source here, and here you have one your current source, here also you have one independent current source, right. So, let me clear it. So, let us go to the next one, or directly I am writing then here actually because after we have solved so many problems. So, here we are writing that apply KCL at node 1, like look if you apply KCL at node 1, right. First thing is this is your ground potential, just let me adjust it little bit, hope it is okay, right. So, now no question of I1, I2, nothing is written. So, if you look into that this is your ground potential. So, at node 1 this is your node 1, you apply this thing. So, one is that your V1 your upon 2. So, this current is leaving, say this current is V1 upon 2, this is 2 ohm resistance. So, this is V1 upon 2, right. Another thing is this V1 and V3, and here you have 1 ohm resistance, it is gone up, but you bring down the circuit you will have 1 ohm resistance. So, if the current is going out here also, right, it will be your what you call that your V1 minus V3 upon 1. So, this is V1 minus V3 upon 1, right, plus another current is going, right. Similarly, like previous one, you have here also one 6 ohm resistance and 40 volt source is there. So, in this case, similar way you find out what is your this current. For example, if I take current flowing this thing is I, if it is a I, right. Let me clear it, clean this thing, then it will be easier for you, right. Suppose this current is I, and this is with respect to ground, that means this voltage actually V1, this is V1, right, plus minus, and similarly this voltage your plus and this is V3, this is minus, right. Just hold on, this plus means this voltage plus, this is the voltage source is there. Now, what you do, you apply KVL in the clockwise direction. If you do so, then it will be 6 into I, then minus, it is encountering minus for terminal first, that is your minus 40, then minus 40, right, plus V3, because it is encountering plus terminal plus V3, then here it will be minus V1, minus V1 is equal to 0. That means your I is equal to, it will be V1 plus 40 minus V3 divided by 6. This is your I. So, all this current and this leaving the terminal. So, that is V1 by 2 plus V1 minus V3 by 1 plus this I we have taken V1 plus 40 minus V3 upon 6, that is equal to, this is equal to 0. I hope you have understood this, right. So, let me clear it. So, similarly at node 3 and node 3 and node 4, so listen, this is not, here should not apply, this is actually just intermediate point you have been asked. This is V1, V3 and V4, these 3 nodes are there. Similarly, V3 and V4 you please apply your what you call that your KCL, right, and then accordingly you please solve it. So, I have explained everything to you. So, similarly, if you write at node 3 and node 4, then you will get this equation, right. Node 3 if you write, you will get this equation, and node 4 if you apply, you will get this equation, right. So, finally, upon simplification, this is equation 1, this is equation 2 and this is equation 3. So, at node 3 you will apply and at node 4 you will apply KCL. I am not writing further. I hope you have understood everything and please do it, right. So, because so many examples similar type and different how to take it have been explained. So, this way you can take it. So, if you solve this one, then you will get your V1 is equal to 10 volt, V3 is equal to 20 volt and V4 is equal to 15 volt. Finally, you have to find out that what is your V3, V2 has been asked to find out, right. This V2 has been asked to your find out. So, if you try to find out your V2, say this one. So, if you try to find out V2, say this is my V2. So, plus minus you take and this is your V3, say plus minus, this is your ground potential, right, and you take KVL like this. So, it will be minus 40, because it is, if you go clockwise, it is minus terminal encountering path plus V3 minus your V2 is equal to 0, right, because we have to find out V2. Therefore, V2 is equal to your minus 40 plus V3, right. So, I think V3 we might have got 20. So, it is 20. So, it is minus 20 volt, that is V2, right. So, let me clear it, and right. So, here your V2 is equal to 20 minus 40 minus 20 volt, because V2 we got your what you call V3 we got 20 volt, because I told you that V3 we got 20 volt. So, ultimately it is minus 20 volt. Hope you have understood how to compute the voltage at any point, right. So, what you will do is, for your just for your own practice, suppose if it is something here it is given this volt or that volt, right. What you can do is, for your this thing, you find out how much power is supplied by this is not given in the problem. I have also, but I have also not solved, but find out how much power is supplied by this 6 6 ampere current source, this 10 ampere current source and this 40 volt voltage source, right. So, you find out that how much power, and then power absorbed in the each resistor you see, then you make that your power absorbed is equal to power supplied, whether it is correct or not. If you get matching, then your answer is correct, otherwise somewhere some calculation error is there. So, this is an exercise for you, you should do it, right. So, with this node voltage analysis is over. Next we will go for mesh analysis, right. So, mesh analysis is a general procedure for analyzing circuit using mesh current as the circuit variables. Actually, whether you use nodal analysis or mesh analysis, actually it depends on your what you call that you, from your observation you have to see that where number of equations will be less, such that your computational burden will be less, right. As the circuit variable, using mesh current as circuit variables is convenient and reduces the number of equations that must be solved simultaneously. So, a loop is a closed path with no node. I have underlined this. a loop is a closed path with no node passed through more than once. A mesh is a loop that does not contain any other loop within it, right. So, later I will tell you that what is the loop. Sometimes loosely we talk mesh and loop, but slight difference is there, right. A mesh itself is a single loop, right, but in a loop there may be other loop also, right. But whenever the mesh is a single loop, there may not be any other loop inside it, but in a loop there may be other loops also. Later we will see that. So, that is why a loop is a closed path with no node passed more than once. A mesh is a loop that does not contain any other loop within it, right. So, this there is a slight difference between your loop and the node, right. So, a loop and the mesh. So, this is mesh and this is loop, right. So, just let me clear it. So, for a given circuit, nodal analysis actually we apply KCL to obtain unknown voltage, while mesh applies KVL. So, nodal analysis all through we have seen we have applied KCL. For mesh analysis we will go for KVL to obtain the unknown currents. So, mesh analysis is not as a general as nodal analysis, because it is only applicable to a circuit that is actually planar, right. That is actually applicable to a circuit that is actually planar circuit, right. A circuit that can be drawn in a plane actually, that can be drawn in a plane with no branches crossing one another is called planar circuit, right. So, a circuit you can draw it in a plane and with no branches crossing one another is called a planar circuit. Otherwise, it is non-planar circuit. You cannot apply your mesh analysis, right. So, let me clear it. We will move little bit up, right. So, a circuit. So, just 1 minute. So, a circuit or what you call may have crossing branches, but still be planar if it can be redrawn such that it has no crossing branches. Suppose diagram is given, it is crossing branches, but if you can redraw such that there is no crossing branches, then circuit may be planar, right. So, non-planar circuits can be handled using nodal analysis, but they will not be considered. Here it is written book, actually book is not written, it is actually you read it as a chapter. Few places you will get it is in a book, but book is not completed, right. So, you read it as a chapter, do not read it as a book, right. So, analysis that will not be considered in this chapter, right. So, for the purpose of just 1 minute, for the purpose of understanding. So, book should not be written, many places you may find, but please read it as a chapter. For the purpose of understanding, you have to consider this path, right, and then we will see the difference between mesh and loop. But thank you very much, we will be back again.